Today I want to discuss with you how you can factorize a polynomial expression with degree 3. We want to discuss the sum of two cubes, how you can factorize sum of two cubes and difference of two cubes, and the application. Now, if you have, for instance, a raised to power 3 plus b raised to power 3, and you're asked to factorize this, a raised to power 3 plus b raised to power 3, this is sum of two cubes. Supposing you're asked to factorize. Now, I may decide to take one of the factor, I may decide to take the first factor. I will look for the divisor. In other words, I will look for a number that can divide this a cube plus b cube without any remainder, with a remainder of 0. And so if I decide to take this base and this other base as my first factor, a plus b as my first factor, I want to be sure that this is actually a factor. You remember, if they say factorize this, what they want from you is a factor. Factors means they are looking for what will divide this with a remainder of what? 0. Now, if I say a plus b can divide this with a remainder of 0, then I want to show whether it is true, whether that is possible. Then I have to now use the factorization, division of polynomial, where this is a cube and this is what? B what? Cube, and then a plus b. In other words, I want to use a plus b. I am considering a plus b to be one of my factor. I assume it. And so if I want for me to be convinced and be sure that it's a factor, I will try to use it to divide the expression. If you use to divide the expression, there are two things you will see. You will get the remaining factor, and you will also be convinced that it's a factor if the remainder is 0. If we divide and the remainder is not 0, therefore a plus b cannot be what? A factor. But if you divide and the remainder is 0, then a plus b is a factor, and whatever you have as a quotient becomes the other factor. So that's the two things you stand to get by the time you divide this. Now, let's quickly divide. Now, I've done a complete video on division of polynomial, addition, multiplication, subtraction, and degree of a polynomial. If you are new, if you are watching this video for the first time, please, I request you go look for that video. If you type medical science lecture room, you will get to see my videos. Now, but I will equally drop the link to those videos at the comment section, so that will help you to access those subtopics of what polynomial. You need them. Now, let's go straight and divide. Now, if we are to divide, we will use this is the first term and this is the second term. This is the first term and this is the second term. You watch carefully. You see that I will use this a to divide this one. And I say a into this, that will give me a cube, a squared. That's a cube divided by what? A. That's to say a cube divided by what? A. Of course, this will be 1 and 1 will cancel here. You'll be left with what? A raised to power 2. And then a raised to power 2 times this. The moment you have written that here, you have to use this to multiply what is to multiply the divisor. And so a square will multiply this. That will give you what? A what? Cube. Now a square will multiply this. That will give you plus a square b. After you have used this to multiply the divisor, the next thing is for you to draw this line. And drawing that line means you have to subtract. You have to subtract because you want to eliminate a cube. And so I will decide to put a minus sign here. Why am I putting a minus sign? Because I want to make sure that a cube disappears. That is the rule. The a cube must be eliminated. Which is why when you have used this to multiply this, the first term here must have the same word power. They must have the same power. If they don't have the same power, they cannot subtract each other to become 0. So the powers must be the same. And so a cube minus a cube, that will give you 0. That will be 0. You now see that after subtracting a cube minus a cube, the next thing you have here is a square b. A square b is not found here. The fact that you're not seeing here, you can decide to bring it. If I decide to introduce it there, I will say plus 0 a square b. Then plus b. This b cube was there from the beginning. So I have introduced 0. The reason is that when you're subtracting, like terms must subtract each other. So 0, I have introduced a square b, but what I introduced comes with what is 0 as its coefficient, so that 0 times this will turn to 0. It means that it does not affect what we were given. So 0 minus a square b will give us what? Minus a square b. And then b cube minus 0 here. There is 0 b cube here. This b cube minus this 0 will give us plus b cube. Now, again, because this a is power 2, this a is power 1, I'll continue to divide. Normally, you have to continue to divide until the point where the power of the a is less than the power of this a. Now, I will now say a squared, this a into this. That is to say, minus a squared b divided by what? A. This will cancel one of the a's here. You have minus ab. And that minus ab times this will give us minus a squared b. Now you now say minus ab times this will give us minus ab squared. Remember that this is multiplying everything that consists of what? The divisor. Now again, you draw this line. You subtract. If I introduce a minus sign, I will now have minus a squared b minus a squared b. Of course, that will be what? 0. And then again, you see this is minus a squared b, but on this there is no what? Is ab squared. There is ab squared here. This is ab squared. But here there is no what? ab squared. I may decide to introduce ab squared. So if I do so, that will be 0 ab squared. Remember, there is still b cube here. And so at this point, I will say 0 minus ab squared. That, of course, will give me what? ab squared. And this b cube minus 0 here will give me plus b what? Cube. What do you see? The a here is raised to power 1. I will now say a into this. That will give me what? Plus b squared. B squared times this will give me ab squared. B squared times this will give me what? Plus b what? Cube. And then you subtract. When you subtract, this will be what? 0. Now, because this is 0, or ab squared minus ab squared will be 0, b cube minus b cube will be what? 0. Because it is 0, it means that the remainder is 0. And because the remainder is 0, it means a plus b, which was your divisor, that was what we were using to divide, it's what? A factor. And because it's a factor, the answer you got here, this is the answer we've gotten, this one will also be the second factor. And so we've gotten the second factor. This thing is like saying 8 divided by what? 2. By the time you say 2 divided by if you say 8 dividing, if 8 is dividing 2, you know that the answer will be what? 4 remainder 0. Then this 4 is also what? A factor, which was a product of what? The division by 2. So at this point, we will now say that the factors a cube plus b cube is equal to a plus b into what? A squared minus ab plus b squared. So, of course, by right, it's supposed to be plus the remainder. The remainder is 0, which, of course, even if you had this 0, it will still be what? So, if they say factorize a cube plus b cube, this, therefore, becomes what? The answer. What that means is that this, of course, represents the divisor, and this represents what? The quotient, and this represents what? The expression itself, the polynomial that was given. And so, sometimes you may have in the exam, they may not say factorize this, but they may give you a question that will require this knowledge for you to answer that question. Factorize 27x raised to power 3 plus 8. Now, you see, this is a question that requires your understanding of sum of 2 cubes. So if you do not understand how we factorize sum of 2 cubes, you may have problem with this. Now this one may not require you to use for you to use your long division method of polynomial. But if you can remember that the sum of 2 cubes is equal to this, you can relate it to this one. But before you do that, you must justify whether this is actually sum of 2 cubes. Remember that for you to say sum of 2 cubes, that expression must have 2 terms. Of course, you see a cube plus b cube. This is the first term and this is the second term. Two terms. Ask yourself, Does this have two terms? That's correct. This is a term, this is a term. Two terms. That fits in correctly. Now, but the next thing you need to ask yourself, if this expression has two terms, just like the sum of two cubes, two terms, that's correct. But again, for sum of two cubes, you see that before the plus sign, the term before the plus sign has the power of 3. And the term after the plus sign has the power of what? It's raised to power 3. But for the equation given to us, you notice that before the plus sign, everything here makes up the term before the plus sign. It is only part of it that is raised to power 3. By right, everything here is supposed to be raised to power 3. And everything here should be raised to power 3. So it therefore means that this is not perfectly in the shape of what? Perfectly in the form that will attract applying the sum of two cubes. So for you to go ahead and apply the sum of two cubes, you must write it in a proper way. So what I'm going to do now, I will now say, instead of writing, I will try to express 27 in such that there will be a power of 3, for which I will now say 3 raised to power 3, because 3 raised to power 3 will be 27. Then x raised to power 3. I will now say plus 2 raised to power 3, because 2 raised to power 3 will be 8. You can see I have now raised after the plus sign, what you have here, this is a base raised to power 3. Before the plus sign, everything is also raised to power 3. Look at it. Because this one is raised to power 3 and the x is raised to power 3, we can possibly take 3x all raised to power 3. Then plus 2 raised to power 3. So what you see is that everything before the plus sign are all raised to power 3, and everything after the plus sign is also raised to power 3. That means this is perfect. It is in the form of what? A cube plus b cube. It's in that form. And because it is in that form, you can therefore apply sum of two cubes. Now, if we compare this with this, if you compare the two, it means that the whole of course, you know that this is a base. 3x in this case is a base. That means this is equal to this. That means we can say a is equal to 3x. Look at after the plus sign, b is the base. B is a base. Now after this plus sign, 2 is the base. Therefore, we can say b is equal to, in this case, letter b is what? 2. And so we will now say, with that, we can now say that 3, remember that we can recall, if you recall, from the sum of two cubes, we were told that a cube plus b cube is equal to a plus b bracket a squared minus ab plus b squared. Now, but our question, we have 3x. From our question, we have 3x squared plus 3s cubed plus 2 cubed is equal to. Now, we have said that our a is what? 3 and the b is 2. It means we have to substitute. In place of a, the value is what? 3x. We have 3x. Now plus b, the value is 2. We saw it to be 2. We open the other bracket. A here is 3x. And because this a is raised to power 2, this 3x must also be raised to power 2. Minus a again, 3x times the b, which is 2, plus the b, of course, is 2. And because this is raised to power 2, this has to be raised to power 2 as well. And so this is equal to 3x plus 2 bracket 3 times, of course, this is raised to power 2. That will give us what? 9x. 3x times 3x, 9x squared. That will be 3 times 3, of course, that's 9. X times x, that will be x squared. Then minus 3x times this will be 6x plus 2 times 2. That will be what? 4. So you have this. This is the answer. So we can now say that 27x cubed plus 8 is the same as 3x plus 2 into 9x squared minus 6x plus 4. That will be the final answer. If you multiply this with this, the answer, you get back this. So you can see when you do that, you have factorized 27x cubed plus 8. So supposing we do not know that a cubed plus b cubed is given this, or is exactly this, we wouldn't be able to solve this problem. So at this point, I want to believe that you have understanding of how to factorize sum of two cubes. There will be another video. There is another video for how to factorize difference of two cubes. This is part of what the application of division of polynomial. Like I told you earlier, there are videos I have made on degree of a polynomial, addition, subtraction, multiplication of polynomial. So I will request that you go watch those videos, subscribe to this channel, like the video, share them. If you have any question, go to the comment section, drop them, and I will respond. Thank you.